What does light experience? Not what it does, not how fast it moves, but what it goes through, if anything at all. Because light travels at the fastest speed the universe allows. Nothing with mass can reach it, nothing can exceed it, and according to special relativity, the faster something moves, the slower time passes for it. Not metaphorically, not psychologically, but physically. If you get on a spaceship and start accelerating faster and faster and faster, your clock begins to drift. To someone standing still, your seconds stretch out. At 90% the speed of light, time noticeably slows. At 99.9, it crawls. Push closer and closer to light speed, and time dilation doesn't just increase, it explodes. Mathematically, it heads towards infinity. So now the obvious question, if something actually moves at the speed of light, like a photon, does it experience no time at all? Let's imagine it does. A photon leaves the surface of the sun, it travels 93 million miles of space, it reaches your eye about 8 minutes later. That's what you see. But from the photon's perspective, those 8 minutes collapse. Not to a second, not to a fraction of a second, to nothing. Zero. Which would mean the moment it was created is the same moment it arrived. But wait, if light experiences no time, then shouldn't we as outside observers see the opposite? Shouldn't it take forever to get here? If one side is zero, well, shouldn't the other be infinity? No. And this is where reality stops behaving symmetrically. Because there's a rule hidden inside relativity that quietly breaks this logic. You can describe the universe from almost any point of view, but not from the point of view of light. There is no valid frame of reference moving at the speed of light. It's not just difficult, it's undefined. So, from our perspective, light always takes a finite amount of time. Always. 8 minutes from the sun, 4 years from the nearest star, and millions of years from distant galaxies. But let's leave light for a second, because this idea that something can approach a limit but never quite reach it shows up in a place that seems completely unrelated. Imagine you're walking towards a wall. Before you reach it, you must cover half the distance, then half of that remaining distance, then half again and again and again. Now each step gets smaller, but there are infinitely many of them. So, how did you ever reach the wall? Now this is an ancient paradox, over 2,000 years old, from a Greek philosopher named Zeno of Elea. And on the surface, it suggests something ridiculous, that motion itself is impossible. But we all know that's not true. Because you can walk to a wall, you can move, so what's going on? Now, the trick is this. Even though there are infinitely many steps, their total distance is finite. They converge. Infinity doesn't always mean forever. Sometimes infinity sits neatly inside a boundary, and that's exactly what's happening with light. When we say time goes to infinity as you approach light speed, it doesn't mean that time literally becomes infinite in a real observable way. We mean that math is approaching a limit, a boundary it can never cross. Just like you can keep having the distance to the wall forever, but you still reach it. Now flip that idea. For light, instead of stacking infinite steps to reach something, everything collapses into a limit. From our perspective, light travels across space. From the edge of math, space itself contracts. The distance between where light starts and where it ends approaches zero. So what looks like a journey to us doesn't look like a journey at all at the limit. And now we come back to the original question. Does light experience time? Now, here's the truth. Physics doesn't allow us to answer that directly. There is no valid point of view for light. No clock you can attach to it, no perspective you can step into. But if you follow the math and ride it all the way to the edge, you find something eerie. Time approaches zero and distance approaches zero. which means, in a very real limiting sense, the beginning and end of light's journey become the same event. Not because the universe is breaking, not because time is an illusion, but because at its extremes, reality stops matching the way we're used to thinking. So, no, light doesn't take forever to reach you. It takes exactly as long as it should. But at the edge of physics, where speed hits its absolute limit, the very ideas of time and distance start to collapse. And the line between here and there, it's a lot thinner than you would expect.